Hi, and welcome to exercise 1 for the DFC course. In this video, I'm going to tell you how and what you have to do in the different exercises, which files to find, and some hints about how you can solve these exercises. This PowerPoint is also on the SharePoint, where you can navigate through it and look at it without having my face on it or having to pause a video. So you can just find it there as just a PBTX file. The exercise 1 is about EVs versus local trains. So we're going to be working with a slightly modified Fredonia model, which I'm calling other country. So in this case, this is our task, that other country is seeing high sales of cars, which could be a problem. So they are going to decide between 3 different policy options for the future. So either they can just let it be and let the have the projection of the sold gasoline cars as they have now. That will function as our baseline and is more or less already filled out. The second option is they could transition towards battery electric vehicles, so battery electric vehicles, as a 50% in 2030, and then see what that will do to systems. The third option is that instead of letting people buy a lot of cars, they can add local trains, which will diminish the sales of cars, both electric and gasoline in the future. So your task will be to add cars and trains onto transport. Transport is in the start set empty. So you will have to add those in the model. Then you will have to add 2 car technologies in the model. So they have to have their own folder, and they have to be vehicle stock turnover. Then you also have to add a separate folder or a separate technology, which is called trains, which is modeled with the energy intensity method. So an energy intensity technology, the small gray gears. There will be 3 scenarios. There will be a baseline scenarios with a bunch of gasoline cars. Since they're not already there, you also have to input this baseline scenarios, but only for transport. The rest of the system is there, but you don't have to touch the rest of it. The second scenario is EVs as a 50% of sales in 2030. And the third scenario is trains fulfilling a large chunk of the demand in 2030. So in terms of what you have to input for all the different vehicles, this is what you have to input. The existing stock, and we're talking current accounts now, if that wasn't obvious, is 1 million vehicles in the system. In the sales of all the vehicles is going to precisely level out the retirement for vehicles in 2010, and by 2040 it should be the same as the retirement multiplied by 1.2. As a bit of a hint, then remember that you can choose your different variables using the little E icon when you're putting in the expressions. So there you can find the different variables that comes out of the lead model and is also in the lead model. So if you have something like same as retirement, that might be something you can actually find and put into your model. You will have to use a bunch of profiles in the model. These are added in current accounts if you remember. Otherwise, look in the video on transport stock turnover. So it's important that you choose the right ones. I haven't decided. I know all the profiles work and they are in the model already. So you just have to choose the right one, the appropriate one for your model or for your input data. So you will have to add some cars to the models in the car scenarios. So this will be the baseline scenario and also in the EV scenarios. So there are 2 types of cars: ICE vehicles, which is just gasoline vehicles in this case, and battery electric vehicles, which should only see sales in the EV scenario. So here I won't list them all up, but these are the fuel economy, mileages, the sales shares for the 2 different scenarios, that are for between these two different vehicles. A thing to note that I mentioned in other videos or in lessons, only apply changes where you want to specifically have a change. That means for something like this where you have the same technologies, base technologies in all your scenarios, but it's just really the difference is how much of it we sell. You don't actually have to input all the EV technologies only in the EV scenario. You can input all of it in current accounts. Just having one variable that means make sure that there are no EVs in the actual system, but that the technology does exist in all scenarios. This could be quite obviously be something like the sales share. So if there are no sales, there will be no vehicles in the system, but you can still have the technology in your scenario ready for if you have to make changes later on. That also makes it much more simpler to edit later on if you just have only one change in the scenario where that is appropriate. You also need to add local trains to the model. The same rule applies here. You can easily apply the technology itself to the current account scenario, because we just need to make sure that it doesn't see any activity in its own in other scenarios except for its own. So that's just a hint to the model. This is just the activity. It is based on the transport passenger kilometers that is found in key assumptions as transport demand, defined as a large number of yearly passenger kilometer needs, which is just one fixed number. Then in the gasoline vehicles, you will have to also do a change in that in terms of the sales. So the addition to local trains to the model means that in 2040 the sales of new vehicles is only 40% of the retired vehicles. So people are choosing not to buy cars based on the fact that they can just take local trains instead. So that's a change you have to do in gasoline vehicles. For EVs, if there should be any doubt, there will be no EVs in this scenario. So in this in the results that I will come to in a second, it is also noted that you need to show the scenario differences in the effects, specifically THG. So you need to add effects. If you remember that, you can see in the video for effects, which I think it was in lesson 3, beginning of lesson 3, you can add multiple effects at one time, and that is suggested to do this in the model. If you do that, it is important you have the right one, so I can check results. And this one we use the IPCC Tier 2 default emission factors, and we choose the US motor vehicles uncontrolled gasoline as the normal cars throughout our model timeline. So what results do you need to calculate and to send to us in the survey? Well, we want to know what is the final energy demand in 2040 for the full system. That's just an absolute number, so I want the one that is for 2040. I want it in terawatt hours, and I just want it in a whole number, so no decimals in this case. We just want the whole number, and you want that for all 3 scenarios, so we can look at them. What are the social costs for 2040? We are going to have that as a cumulative cost in million USD. I want it in a whole number, and I want it for all 3 scenarios, and you can input that in the survey as well. And then also we want what is the cumulative GHG emissions from transport, not the full system, transport itself, in 2040. I mean all the years up to 2040, because it's a cumulative number, and I want it in million tons of CO2 equivalent, and I want it in a whole number, and I want it as allocated to demand, including transformation. So when you look at the results and you're looking at your effects for that, there is a few different options. I want the one that's allocated to demands, including transformation, because otherwise we will not get the effects or the GHG emissions that comes from utilizing electricity in both the trains and the electric vehicles. I wish you good luck with the exercise 1. Remember to note down your different results, as you have to fill them in the survey with the 2 other exercises as well. So you can only fill that in after you solved everything. So have a piece of paper or somewhere in your computer to store your results, and good luck with it.